Hello, guys. It's on? Okay. Good morning. Uh, I'm so excited to be here. It's my first time in the US. It's uh, it's the first time I traveled 20 hours on a flight. So it's a lot of first time for me, and it's really good. It's going to be hard for me to follow up Ernie's talk, but I'll do my best. At least it's going to be the first technical talk of the day. So my name is Harisankar. For those who it's hard for you guys to pronounce, I'm also known as Harris because all my clients also can't speak my name. And everywhere in the World Wide Web, I'm known as CodeRiches. So Twitter, GitHub, anywhere. And if you know some place where I can register username, let me know. So I can be CodeRiches there as well. One thing about me is that I really love stickers. I know that a lot of you guys might be having your company stickers or your group sticker. Please give them to me, okay? And I'll give free promotion wherever I go, as you can see from this. I work at a company called Red Panthers. We are based in India. It's a dev shop. We are 12, 15 people of us working around the clock. I'm the founder and CEO, but I'm also a programmer. So right now, I'm working also as the head of programmer at Synchronous RFID Solutions, based in the US. So a lot of the things that I'm going to talk about is what I learned when I scaled this application, this really big monster that a lot of us built. So I'm from Kochi, another word that you guys are going to find really hard to pronounce. So we have a lot of elephants, right? We see them a lot of time. We are a coastal city, and we are like a tier-2 metro. So you won't hear about Kochi when you hear about India, but it's a really beautiful place. So if you come down, way south, it's a really nice place to visit. And for Ruby developers here, if you want a place to work remotely when you're there, we have an office space. Feel free to come by. I have an interesting fact about India, is that we have 22 official languages. We have 1,653 spoken languages and 50,000 dialects. And I know 3 of them. So it's a huge country with a lot of diversity. So let's start the talk. Okay, it's actually a story. I'm going to tell you a story about a novice developer who wrote the first lines of code of a web application that was meant to just process like 1,000 rows of data. I still have the mail with me, but the client told me, yeah, it's going to be like 1,000 rows, that's it. And 10 users. I mean, it's going to be just system users, you know. We're not going to have public users. We'll just have 3 of our guys, 2 of their guys, and maybe a couple of developers and some demo accounts, that's it. And then it started growing big. And so big that we have start processing like gigabytes of data every hour, right? And this was me in 2014. So this talk is about what I learned, which helped me and to scale the application without spending so much on the hardware. Because even though we are scaling so much, one of the reasons why we scale so much because the client was giving out our software at a really cheap rate, right? So one of the jobs that I had was to keep cost per tenant down. Every day I was waking up to saying that cost per tenant, cost per tenant. Okay, we have to keep it as low as possible because I want to move 100 more clients to this. And each client is a different store, not users, right? And each store will have like the same 10 users, and it just keeps on increasing. So let me start by mentioning the tools that I use, right? So this is my universe, right? I'm from the Avengers universe, where the Ruby is Captain America, the obvious choice. Rails is Iron Man, right? And database is the Hulk. So the thing is, the Hulk can smash, right? But we use Hulk to carry our suitcases. That's basically it. That was our problem. So as I told, like back in 2014, we were novice developers, right? We were concentrating all on our Rails application without actually realizing that This Rails application uses a lot of ecosystem underneath it. Like we have a Linux, we have the databases, we have Nginx, which is standing in between every request. So every layer, there's scope for optimization where we were just concentrating on Ruby and Rails. And that's when you hear a lot of people saying that Rails can't scale, right? Because people are trying to tweak things that's not supposed to be taken care of by Ruby. Right? Ruby is a programming language. It's supposed to do the business. It's not supposed to care about these kind of things. It's supposed to do what we ask it to do. So we're going to learn how to use the Hulk. We have a Hulk, so please don't be afraid to use it. And a disclaimer, I have done all this in production, so you don't have to feel scared when you try this. OK, so we're going to, some technical terms. We're going to talk about query planning. We are going to talk about indexing, attribute preloading, views, generating JSON, and synchronous commit. So let's start with the first thing, that's a planner. So database is general purpose software, right? We build applications for a specific purpose because no client comes to us and asks us the same thing over and over again, right? No software is unique as no human is unique, right? The problems that I face in India are not the problems that you guys face in the US. So a software builder for the US is not the software you build for India. So, but the database that we all use, it's the same. It's a PostgreSQL or MySQL or Microsoft's Oracle. So it's a database software, and the people who build it do not build it for a single industry, right? You can't have a database just built for the scale of Facebook. You don't have a database that's just built for the healthcare. You don't, like, no company comes and says that I have the best healthcare database that can only be used by the healthcare. No, they always build it for everyone. So how does a database handle all the scenarios? The truth is, it doesn't, right? It doesn't handle all the scenarios, right? Because really smart people build a software, so they build it such a way that it can handle anything in general. But as we grow, it goes specific. So the DB doesn't know what all our scenarios are. We have to nudge it. We have to tweak it. We have to change it. Okay, we have to make the system realize that, dude, I want you to like stream a lot of data. No, I want you to update this thing really, really fast because I'm going to push a lot of data into you, right? I can't have you wait like a microsecond or a millisecond for me to push the next data because I have more data coming in. So a database, we need to tweak it. Another example about this is that the SQL, the structured query language that we write, is actually meant to define how our data is going to be, right? For example, select ID and name, which means I need the name and ID from my table. But we are not telling it how to get this ID or name, right? We as a programmer, we do that. In our Ruby code, we do that. When we have to search through a lot of files, we break up the files, we search each of them independently, and if one of them has the files, we just ask everyone to quit because I found it, right? But when it comes to databases, we take everything for granted. I'm saying that I need the maximum price of a product, okay? Among all the bids that we have, I need a maximum price. So that's it. How is it going to get the maximum price? That's done inside the database, right? The database takes care of it. And since we have a lot of smart people working in this database, we have a lot of powerful algorithms, and we get it really fast, and we take it for granted. And the query planner is the brain of the database who actually decides how to get this data, right? It's the brain. So we have this, so I ask it to do something, but if the query planner thinks that it's the smartest move, then it does it. If it says, no, you're not smart enough, I'm going to do this. Okay, if this is the method, then it's going to do it that way. The only thing is, we will get the data in the way we want. So, well, that's about the query planner. It's the brain of your database. And we need to know the brain if we want to improve its performance, right? We need to know how it thinks so that we can make it think that this is his idea, okay? So that's one thing, okay? You can't tell it to do this. It won't do it. You can't use sudo, right? It's not Linux. So what we do is we make him think that this is his idea so that it will do what we want, like a politician. So query plan is executed by the database before the query is even executed. So we feel like when we say select ID name, we just go and select the ID and name, but no, it has a small step before everything else in which it plans. Okay, it plans. Its plan is basically the cost of running the query, right? Here the cost is the time, or these like the space or the processing, right? So what we're doing, a simple representation would be the number of records it has go through to get this data. If it sees that going through, it can get the same result from 10 rows rather than going to 10,000 rows, then it will go to the 10 rows. That's how it plans the cost. And the query planner thinks that it has the most ideal plan, right? That's it. I have the best plan, and no, I'm right, you are wrong. So we need to see this plan, how the query is going to be executed for the performance optimization to happen, right? So, sorry about that. I hope you guys can see it, but basically there's two plans. One is a plan where I'm searching for a user with ID 1, right? And I asked it to explain, and it says that it got me that result was, we received the result really fast. And the second query is the same, in which I'm looking for asset ID 1, right, in an assets table, and it takes longer time. And the reason here is that one is doing an index scan, while the other one is using a sequential scan, in which one has an index of the table, so it just literally goes to user with ID 1, whereas the other one is actually going, are you it, are you it, are you it, yeah, you're it, okay, let's go. That's how it goes. That's what sequential work. It's plain and simple. And we can only know that if you look at the plan, right? So one of the things that I'm going to talk about here, like on the next slides that's coming, is that even if you have index, the database might not use the index. So you have to look at the plan. So if you're going to build a query that you know is going to like be used again and again and again for a long time, then you have to look at the plan. So if you're just going to fetch a user, you might not want to look at the plan. But if you're going to, like, let's say, generate a report of the user activity, or you're going to create a timeline with all the data, you're creating a log for the customer to see the assets that came into the store, went out of the store, all these things, then it's going to be, every time you load that page, you are expecting it to run again and again. Of course, we'll cache it, but let's assume, like before investing on the cache, loading up a lot of memcache servers, we need to make the database itself run really fast, right? So we look at the plan. So we check the query plan and find where we are slowing down, and then we just fix it, right? We just tell it that not do it. So we can use an index, we can create a summary table, like there's a lot of different steps to do that. That's what I'm going to talk about. And sounds simple, doesn't it? You just take the plan and you fix it. Really good. So let's see how we can do that. Another tip is that you can get the plan in various formats, XML, JSON, everything. So this is the first step. Every beginner programmer who gets mentored, the mentor always says that do not forget your index when you write your migrations, right? Because why? Because index will make things faster. So easiest answer to your performance problem, index everything, right? And we did that once, really. But let's not do that, okay? Because index are special lookup tables that the database uses while it searches for something. And it will improve the speed of data retrieval, and it will take up actual physical memory in your server. So if you create, let's say, 5 index per table, then you will be creating 5 index tables, which is a copy of the row that you are indexing. It's like a pointer to a particular row, so that's why it speeds up, right? If it's found in the index, it gets the entire information of the table in that instant. But you know something, as I said, databases are smart. And even if you have indexes, they won't use it. Why? Because there have been cases in which not using the index is faster. So let's say if I have a 10,000 columns but the content of the entire column is like short, medium, and long. And then the database, it's like it says that rather than going to the index, I can just go sequentially and search everything because I have to still search the entire index table for this thing. So it doesn't make sense, right? And the query planner is what decides this. So the list of tips that I like to say is like what we should index. We should index a primary key, which Rails takes care of. We should index a foreign key. We should index all columns that you are going to put in your where clause. You should index the keys that you're using to join tables. And yeah, we can join tables through other ways other than the IDs, right? You can create your own keys. Like for example, in our case, we have this 24-character EPC hexagonal value, and that was more unique than the database ID. So we just joined all the tables using this. So we have to index that. And you can index the date column if you're planning to use it a lot. And there's something called partial indexes. Anyone who uses Rails have used scope, right? So youth means anything less than 35 years of age. Old means anything greater than 65, 70 years of age. Teenagers means 13 to, so these are like scopes. So you can actually create an index for a scope. So that is also a good idea. And do not index tables that you know there's going to be a lot of read and write. So we had this table in which we are streaming live data. Like, it's not turning off, right? It will never turn off. You will have this table of every single store receiving data nonstop. And we are summarizing it. We are like taking data, like a snapshot of this table, summarizing it, and moving it out. So you just take it, snapshot, move it out. So that's how we do. But this table will always keep on getting data. And if you try indexing it, which means like it's going to pause for a second, find where to place this row in that index, enter it, and then come back. So that pause is not good for us because the application was supposed to get more and more data. We can't put the queue for that much time because the queue was breaking our readers. We had actual device, and this device was not smart enough. So we couldn't like ask them to like slow down. And do not index columns where you will be manipulating the lot, a specific value. Let's say the rank 1, 2, 3, 4. Then you go back to 1, 2, 3, 4. 1, 2, 3, 4. If you like a cycle, then do not waste time indexing it because you know that's going to change. And do not index something that you know is going to always be small. Right? You have this settings table, and it's supposed to be small, and it doesn't make sense. So that's all about indexing. Now next is attribute preloading. So that's something that we are kind of familiar with, in which we have the includes, where we fix the n+1 query problem, right? So everyone who's in Rails always hear the n+1. You have users, then you have the post, so you're loading it's twice. So that's the n+1 query problem, and we have the includes to fix it. So database now has a data structure like arrays. I'm going to talk about Postgres arrays, but all the databases are coming with arrays, right? So if you take the Rails way, okay, this is a real code. So it's a Rails way, and I have a task with all the tags, and I'm including it. And the thing here right now is that I'm having a lot of objects. I'm creating an objects for everything, from the tasks, the tags, and everything, right? So that's too much memory. Of course, if you get to pay for huge clusters of RAMs from Amazon, it's possible, but the problem here is that we had too much queries from every single store, and it was not a good idea. But Postgres allowed us to put it inside a single query and inside a single object, right? Because we just created virtual attributes and placed those IDs, all the names of the tags inside it. So I didn't want the tag, I just want the ID and the name, and that's it, right? Because I have a URL that I need to populate, right? In which you click, you go to that ID, that's it. I don't want everything else. I don't want to know when it was created. I don't want to know when it was updated. I just want what I want to load my view, right? So that's where the Postgres arrays And it was 3 times faster than doing the Rails way. And of course, we use Ruby code as much as possible. So yeah, I know that I'm talking about databases at RubyConf, but we have a lot of Ruby code here inside, so you don't have to be afraid. And the next is the views. So when I started out in Rails, that's the first time I'm exposed to something like patterns, design patterns. I'm sure like some of you can relate to what I felt back in 5 years ago when I started programming. So before that, I come from the PHP world and from system admin side. So I just write a lot of shell scripts and I write small PHP applications and everyone was happy, I was getting paid and life was good. And then I come to the Rails world and they told me that there's something called model view controller and it was like blah, blah, and blah, in which it didn't make sense at that point of time, but you fast forward like 5 years, I can't think of doing anything without a design pattern. I want to learn everything that's with architecting the system, learn the best practices, and just implement it. So when I was working with a lot of complex queries, that's when I realized that this is a really good use case for views. Because what our Rails view does is that it takes data from many tables and displays it for us. So if you take a user profile, it has data from the user table, the log table, the statistics, everything, right? So the databases have something similar to our Rails views inside of it, which helps us join huge queries into a single query. So database views are like our Rails views in which we join multiple queries into a single one. And why would we do that? Because it makes our life easier. So instead of doing select ID, name, email from companies where role equals manager, we just create a view and we can do select staff from company managers, right? So we just create a pseudo table which doesn't exist, which has the data from the company's table, right? Which is good. And the thing about this is these are not real tables. If you take views, they are not real tables. They do not exist anywhere. They just exist in the RAM. So if you create a lot of views, then the schema of this will exist in the RAM. So yes, you will end up taking up a lot of your RAMs. But it makes life easier. And there is no result actually being stored. I'm talking about database views right now. And it's actually running the query every time to get the result. It's just that it just made your life easier. Select stuff from your pseudo table. So that was good, right? And of course, as I told you, people there are smart. And then they realized that we can actually store this into a temporary table. And the story behind this is that people were actually doing it. People were creating views and then storing that view into a actual table, right? So let's say you have a daily report of sales. And we had sales today, we had sales yesterday, and we're going to have sales tomorrow. But the difference is the sales that happened today and yesterday will not increase because it's happened. But the sale that we're going to happen tomorrow, yeah, that's live. We expect more sales to happen. So definitely that's live. So that is a perfect use case for fixed read-only tables in which you just created the view and you just store it into this table, and every time you load this page, it just stores the data which is already recorded from this table. So the concept of materialized views came, where you materialize the view. And it was first introduced by Oracle, now found in Postgres, Microsoft SQL, IBM, DB2, etc. MySQL doesn't have it, but there's an extension for it. I'm not sure whether MariaDB has it, by the way. For some reason, Oracle, of course, not some reason, expected reason, Oracle doesn't care about MySQL. So shift to MariaDB if you are still using MySQL. And yes, why am I talking a lot of SQL at Ruby conference? So let me show you how we're going to use this inside of Ruby. Yes, you still need to write a bit of SQL. I'm sorry, you can't run away from it. Just embrace it. So we wrote a migration for a view, and also up and down. You created the view, and also you destroy the view when it's done. and you create a model for it. You create an active record model for it, right? So this is another beautiful, beautiful thing about Ruby. No, it's so simple, and we just take it for granted, right? Because Ruby being object-oriented, right? We can create objects and design objects for anything. So active record is a representation of the actual tables in our system, which means we can even create models for tables that do not exist, as long as we make sure that all the methods are messages that we pass into that object of the class works. So that's duck typing. Like, quacks like a duck, it walks like a duck, it's a duck. So we could create models for tables that do not exist, right? So even we could create this for a view. So right now we just create for a metallized view, but we can create this for a view in which every time you just call this model, it just runs that query, right? And when you like add chain more methods to it, it just active record just take care of the rest. It's so beautiful. And another thing is that it's read-only. So we need to make sure that no one tries to update it, right? People make mistakes. So we need to make sure that it's read-only, and the data is loaded, which means that you need to refresh it. So only use it where you know that the data is going to like remain the same for some time. You know, it's like, do not change it like you know that this data is going to get changed every single day, then you shouldn't do this. Like I said, like history of sales is good. Logs are good, right? Timeline is good. Like you have this, the user went to this page, he went to that page, he made a sale. Okay, make a view for it, that's fine. Which means the view for what happened yesterday. And once you have this thing done, you can do queries on it, and it's fine. You can actually search by name. You can, let's say you have a report and you need filters, right? Because nothing is easy. The client first asks you to give you reports, then he asks you to give you filters, then he asks you to give you drafts. All those things will happen. So Ruby lets you be flexible. That's why we all love Rails. So, so you can do all the things that you do in active records on this, because we have inherited active record. The first and last do not work, right? Because why? Because we don't have an ID. We didn't create an ID for this. But as usual, Ruby being so simple and so wonderful, and following the object-oriented design pattern, we can assign a field as a primary ID. In which case, this case, I just gave it ID. We can make it name or whatever you want, right? And the benchmarks. We had a system after heavy indexing and everything. It was almost taking 1 second, and we just brought it down to 2.3 milliseconds. That's how much the difference were. And this is the Ruby code that we benchmarked. So, and we did it on like a 1 million random sales, right? This table had 1 million records. And 1 million itself running on just 1 second is good, but 2.3 seconds is much better. And the takeaway is that it's faster to fetch data. We have all this data and it's faster to fetch. We can capture commonly used joins and filters. Let's say, as the application grows, you will end up with Ruby code or SQL that's like 5-6 pages long if you print it on an A4 sheet. And you can bring it down to a single line using this, which makes us easier for us to debug. And we can push a lot of data-intensive processing from Ruby to the database, right? We might be doing a lot of stuff with Ruby in there. Let's say like splitting the terms or capitalize, making it lowercase, uppercase. All these things can be just pushed to the database. And we are just using that single view, which makes it much more clearer, right? And it's a lot of fast live filtering of complex association. This is what I liked a lot. Like if you have like real-time data coming in which one tab is real-time, and all the other tabs is like 1 day, 1 week, 1 month, right? It makes your app really fast. And I'm talking about like, I know that the cache exists, Well, let's not go there right now. If your system is fast even before the cache comes in, then it's going to be really fast when the cache comes in. And we can index various fields in this view. So that's another thing, because since this is a table on its own, we can even add index onto that, which is good. And yeah, you will be using more RAMs and storage. So I used Postgres. It came in 9.3, the materialized view came. And when it came, then we find that it's hard to refresh, because refresh will block everything, right? Which is bad. We can't have a page saying that please do not use this page right now. We are refreshing. Okay? We had to do it when it was 9.3, and when 9.4 came out, it had parallelism. So we are refreshing concurrently. So we were showing the old data when it refreshed the new data. And of course, in 9.3, we did this manually, right? We just created another table into which we moved the values first, then we just did a copy. Just copy from one table to another. And of course, the drawback is you can't have live data, because if you're going to like keep on refreshing, then it doesn't make sense. And you're like, if you have like a 1 million rows in that table, refreshing is not a good option. Yes, and this is the highlight of my topic: JSON generation in databases. This, if you guys are going to like take one thing home from today, I hope this is it. Why? Because we ended up moving our APIs into the database. So why did database now start thinking about JSON, or XML on the way? Like, the reason is that most of the application nowadays is like HTML and JavaScript. Thanks to the Node.js, the more front-end AngularJS, React.js, all those things, right? People started thinking about having everything in JavaScript. So databases start thinking about serializing data. So when you write an SQL, you get a serialized data of 1 million rows. And you can serialize data in many ways. YAML is there, JSON is there, XML is there. So the database only supporting a single format is not making sense for the modern world. So the people who build databases start thinking about this, because another way to get the attention of the database creators is that you make a third-party extension that does it, and it becomes really popular that they finally understand that we have to take it, right? So all these things start out with third-party extensions. And if you take a web framework, like the JSON is the glue that binds everything together. And it's natural for the database to support more JSON because of that. And if you take Postgres, we have a single query that converts the entire row to JSON. And that's it. You have the entire user as a JSON. And it gives you this, which is not good. It gives you every single thing in that row as JSON. And it even gives you the password, everything. But for more practical use, we just make the entire row to JSON. We write a query and then convert that query to JSON, which is good, right? So I have this API that gives the ID and email, which literally is a production API, because one of the readers just want to know who is the admin of the store. That's it. So that he can display it in that. So there's a web page for the router, and the router will display whom to contact for that store with this API. And yes, we can go more complex. So if you want to like take data from multiple tables, and you end up writing more and more SQL. And this like 5-7 lines of SQL gives you this 2-line result. So, and yes, I have used so this is another example where I used the attribute preloading. So it gave you an array of all the projects that I'm doing. And let's say that you want to build something which is not part of the database, right? Just generate some random key that you want to send along with every single JSON API, and you can do that. There you have the JSON build object method that just creates anything. So foo1 bar 2, and it gives you the foo bar JSON. And yes, the question that everyone is asking, so where is Ruby? So there are gems that actually does that for us. Abstracts away all this SQL so that we can create much more readable code. And you can, like, with this gem, you can just pass in like a query and do all the extra attribute preloading. But for more complicated querying, you might still end up writing SQL. So Rails just became just an interface to just do the query, and the query has the result and gives it. It does zero business processing there. Like none of the logics for that API happens there. It's moved to a view, and it just converts this view into a JSON and send it to the client. But like me, when you keep as much of stuff in Ruby as possible, create materialized view, and then use the gem to generate the JSON. And over time, I'm expecting that we might even just remove that Rails part from the equation and make Nginx take care of it, right? But that's a different conference topic, maybe next year. So the benchmarks, so I had these APIs that were taking like 2 seconds, which was fine because we had like a couple of one APIs for one store, which was good. But when we moved it into the database, it became less than 200 milliseconds. And it even went to like 50 milliseconds on that scale, which means it's faster than what you can see. And if you take the request per second, it's some of the things that I found online. We had one thing in which was running at 25 requests per second, which scaled to 330 requests per second on the same hardware and same everything. And the final thing is the synchronous commit. So as I was saying that most databases are built to be fault tolerant, because you can't have information about money in your database and say that your database crashed, so I have no idea where the $100 went to, right? Banks won't use database if that were to happen. So what most databases do is that they create a log. Okay, account A is going to get $100. Okay, wait, let me write the log. And now, okay, give me the next one. It goes like that. But you don't have to do that for, let's say, raw reader data that I was using, right? I'm getting a lot of data in which it was ping. I'm pinging this device every 1 second. Are you there? Are you there? Are you there? It didn't. If I lose 10 seconds, it was fine. So database has something called synchronous commit. If you disable it, then it will stop writing the log and just start saving stuff to the database and offload writing to the log later, right? Asynchronously. It just moves it out. And the size of data that we're going to lose if the system crashes is the size of the log, which is like 4 megabytes. Okay, and in our case, we made it to 64 megabytes, but still, losing 64 megabytes of data was fine for us. So there might be some data that you don't mind losing in which you can do it. Let's say if you want to import a CSV, right, in which you have no issues doing it multiple times if the system happens to crash. So you just synchronous, disable it, do your CSV import, and then validate that the CSV import was successful, right? If not, you just say, sorry, we have some problems, so we're going to try again. That's it. The user is fine with it. And it won't corrupt your data, but you will lose data if the system crashes. What people fear about this database corruption, it won't corrupt. You just lose data if the system loses. That's it. And this is a config that I used. So, and we wrote this in a YAML file, ERB file, and put it inside our Rails application, because over time we were starting to move to multiple databases as well. So we can tweak everything, right? You can make the system. The system is built to be fault tolerant and reliable, but you need this to be the fastest machine that you can build. So you have to be able to change it. So you can increase many of the parameters. So you can find all these things here. And to summarize, index data so we don't end up scanning the entire database. It's really important. Use arrays for data preloading. It's going to take some effort, but it's going to be worth it. Simplify the way you fetch the data using views. Move more of your complicated JSON. Like if you end up writing a huge service for generating your JSON, then think about moving parts of it or the entire stuff to the database. Disable synchronous commit if you know that if you lose a couple of data, you can always bring it back, or you can try again. And my conclusion is know your tech stack. So one thing that we learned in all this process is that we are not just Ruby programmers, we are programmers. So we are going to use a lot of other tools other than Ruby. We're going to use a text editor, we're going to use a server, we're going to use databases, cache. So know your tech stack, know your team, right? Know their strength and weakness so that you can fix it. And you should have more control of your moving parts. So data coming to database is really important. So I'm not a DB admin, but I still need to know, right? So also, like, there might be a lot of people trying to hack your system, and you can block it at the Nginx level itself. Of course, I'm not a system admin guy, so I should still know it. And SQL has been around for like 40 years, and it's still planning to remain here. So taking an effort to learn it is going to be useful. And finally, there is no golden rule for anything, right? Things that work for me might not work for you. Something that worked for me might work for you. So please always keep iterating. I've blogged about this more details, about this in more detail in our company's blog. Thank you. And these are the many languages.